Thank you, Jorge, and good afternoon, everyone. Very brief run through a journey on how you would get a turbine installed. Trying not to be technical, I'm a lead engineer in the innovation department with SP Energy Networks. As I say, I'll try and keep it fairly low-level technology. So assuming you were a consultant and you were looking to install a wind turbine, what are the sort of factors involved? To start off, you would need to find an area that's got suitable wind, and then you would need to choose some locations for your turbine. So having chosen 3 locations, you would then want to know how to apply for a grid connection. And at the moment, in the existing, well, if I say that, have any of you been involved in wind turbine applications or the supporting documentation for that? Have you had the pleasure of going through the pain of this? Existing application process within SP Energy Networks, and that applies to other DNOs, is that effectively you put in an application with your location, your intended generation device, its size and type, and you wait. Now, most people go in for formal quotations, and under guaranteed standards, we have to respond to these within 45 to 65 days, depending on the voltage level. You can get an estimation a much shorter period, but for some reason, everybody goes for the formal quotation. So currently, you may wait up to 65 days to find out a price. And the connection cost will vary. You may wonder, why should it vary? Why can't I just connect at the nearest local overhead line? Well, there are a few reasons for that, of which I shall touch on. So at the end of this 65 days, you receive a quotation and you go, not on earth. You know, it's in the hundreds of thousands of pounds. What good is that to me? Limiting factors very much revolve around generator output voltage at the point of connection to our network may require laying cable towards the source primary. The other sort of limiting factors are size and type of conductors that exist on our network, existing generation on the same circuit or interconnected at that primary source. It may be that the primary or secondary transformer to which you're going to connect has no further reverse power capacity. These will influence the cost. So, the problems we currently have, both internally and externally, limited visibility of network capacity. It's where we have no direct visibility of the available capacity. Today, all quotations refer to firm connections, which means no constraint or limitation required. Internally, to carry out this work actually requires an awful lot of man hours internally, and so that's a large cost currently borne by our business. And for all the applications made, only 10% actually come to fruition. So this is not sustainable for us as a business. At the peak of applications, a couple of years ago, we were dealing with 40 requests per week, which absolutely flooded the business. So we recognized we had to do something different. So the solution, online curtailment analysis tool, fortunately shortened to OCAT. It's a bit of a mouthful. Even people who've heard of this before keep forgetting what it's all about. But the objective was to create an online tool that can be used by customers to understand how active network management, I'll come back to that in a minute, can facilitate network capacity by their individual project ahead of formal application. Basically, looking to provide customers with visibility of network capacity to assist in planning new generation projects. We're also looking to provide up-to-date and accurate information on the network and provide enough information to enable customers to make an informed decision on the feasibility of an application. Active network management means taking some intervention to the generation point, no matter what the technology is. But predominantly at the moment we're working with wind and solar, which is all quotations to date have been what's called firm. That is, no action is taken. And the move forward now into the more active network to move towards smarter grids requires intervention. So, using OCAT capacity estimation, you suddenly see for these same 3 points that we previously looked at, we now come up with 2 different costs. Firm, previously said, was a connection where we take no intervention, and that is traditional connection, as you would see at the moment in time. But within this project, we've been working towards providing a non-firm solutions. The non-firm connection is cheaper to install, but what it does involve is a level of curtailment, maybe 1 to 6%. That's effectively reduced energy for the customer. And this may happen at short periods when the network's operating near its limits. Often on the sort of 11 kV networks, that's at a voltage limitation. 11 kV we very rarely run to a thermal restraint. So the advantages: feasibility at much shorter notice, online, and I have to state estimates only. Cost estimate and revenue indication by units. So, pass over. Now for the demonstration.
Thank you very much, Martin. We will move into actually take a look how the tool looks like. This will work. There we go. So this it sits very well with this particular slot, because this is something that has been developed with Web App Builder Developer Edition. So what we did was to take Web App Builder and develop our own widgets that allow us to create this tool specifically for these conditions. But because it's Web App Builder, we're still able to use all the widgets that are available with Web App Builder. So for example, here where you can see you can vary the base map in case you want to show a different map in the background, helps you to identify particular connection points. You can also use the measuring tool, you can measure distance, and all the other Web App Builder widgets. Also, that means that because the data of this particular tool, as well as the part of the application, is on the cloud, that means that will scale to whatever you need without having to worry about the load they're receiving. It's also quite responsive, so that means that you can use any device. The only thing you need is an internet connection, and will automatically resize the screen and will be reactive to that. So that's another thing that you don't have to worry about thanks to Web App Builder. So what the public will be seeing in this tool that is embedded in the Scottishpower website is this area, where the gray area is the trial area we're using for this first part of the project. And you're received with this heat map that will give you an indication of the network capacity. This is something that's already available in Scottishpower, and it will give you a rough estimate of where the capacity is. So here, red is less capacity, green is more capacity. So as you zoom in, you start seeing the circuits and all the different capacities in them. But what the OCAT tool is about giving you much more detail about the different connection points and the characteristics of your connection in particular. So the first step is to locate a generation location. So let's say, for example, you want to install a wind turbine there in that particular location. OCAT will automatically select the closest connection point, and it will give you a number of values that will be useful for you determining if this is an application that's feasible or not. But the real power of OCAT is that now you're able to, for example, not only test that connection point, but to look at different options. So here's where you're trying to get an application that suits your needs better. So perhaps you want to try that connection point, and automatically the OCAT will recalculate all your variables, your capacity, your estimated curtailment, the distance to your connection, etc. So let's try another connection point, and again, you can look at, and perhaps there's something in the middle that you don't like or something like that, you can avoid it. You can also try different technologies. So if you don't have a certain defined project you want to. You perhaps want to try solar, you want to try wind. You can also modify that as well as the rated capacity. So here you start seeing a tool that's going to give you flexibility to evaluate different types of projects and different conditions for different locations, without having to go and apply directly to Scottishpower blindly in this 60 days period. In certain locations, and depending on rated capacity, as Martin said, you'll have a non-firm connection available as well as a firm connection. So perhaps for you, it's more important to get a cheaper connection that will include some curtailment, but you connect cheaper and faster. Once you have selected your connection point, what you can do as well with the tool, with OCAT, is to modify your path. So if you see that the way the connection path has been selected automatically is not good, because it's crossing something that you know is not going to be feasible, you can modify it. And as you modify the path, all the variables that have been pre-calculated will be recalculated based on this new path. So you'll have a new distance and therefore a new connection cost that will give you a bit more accuracy about that particular location. Also, as you can see, you can look at your elevation profile. This is quite important, especially if you need to create a new line. You want to have that height difference as smooth as possible. So this is another tool that is quite useful when you are starting to apply something that perhaps you won't be able to see in advance and will render your application invalid. So the whole idea of this tool is that what we're doing in the background is quite complex. It's a complex power analysis, GIS combined calculation. The front end and the tool itself is simple and provides just with the data you need by giving you quite a lot of flexibility. So now to explain a little bit more about the power analysis behind this tool, I'm gonna leave you with Martin Hammond from Smart Grid Solutions.
Thanks, Rory. Good afternoon. My name is Martin Hammond. I am the other Martin of OCAT. There are plenty of us. And I'm a smart grid consultant from Smarter Grid Solutions. What I'd like to talk to you about is a bit about what we do as Smarter Grid Solutions, what active network management really is, and why we are involved with the power systems analysis back end, if you like, of the OCAT application. So Martin has already highlighted, the other Martin, the main Martin, the first Martin, if you like, of OCAT, has already highlighted some of the problems which are faced by distributed generators who are seeking connections in these constrained network areas, like the Spen-Dunbar area. And he's touched as well on something called active network management as a potential solution to this. Active network management, or ANM as we like to call it, because we're fond of our acronyms at Smarter Grid Solutions. It's chief among our product offerings, and what it is, what we like to call it, is an autonomous industrial control system for electricity distribution networks, to manage constrained electricity networks and to generally increase the generation hosting capacity of these networks. ANM works by, how have I done this? Yeah, we're fine just now. ANM works by monitoring in real time a number of pertinent conditions on the network, power flows, voltages, that sort of thing, and comparing those real-time measurements against predefined safe limits. If there's a condition where a safe limit is exceeded, then the ANM system acts based on its understanding of the relationship between generators and power flows and voltages and so on the network. It acts to manage the exports of those generators and bring those parameters back down within safe limits. With that in place, you then have the situation where you can essentially connect greater volumes of generation because there is less risk of these excursions, if you like, of safe limits arising on the network. When it's no longer necessary to manage the export in that way, then the generators are released and allowed to return to their full export at that point. It's an SGS active network management system which is in place in the Dunbar network area, and it's controlling distributed generators in response to various constraints on the network. And that puts us as SGS in a position really of unique insight to be able to support the development of this OCAT application. Ahead. So we've developed an analysis backend which handles the network modeling, simulation and forecasting of ANM control actions to produce an estimation of the export reduction which a generator might see when it's in place, connected to the network and operating under ANM control. The SGS OCAT backend starts off by taking GIS data, which is provided by Esri. It's extracted from Scottishpower's geodatabase. We take that information, we parse it, we find the individual network assets, and we identify their defining electrical characteristics. And from all that, we construct a network model, a model of the network in one of a number of industry standard formats. And using that and a series of historical power flow data for the network more widely, we perform a process which we call simply curtailment analysis. This involves running power flow simulations and performing calculations, simulation of A&M control actions, and produce a forecast level of curtailment for each technology and capacity of generator for, as Martin said, wind, solar, and some synchronous technologies as well of various capacities. We pass those estimates back to the Esri GIS front end, where they are displayed in an ArcMap application, along with forecasts of connection time and cost, and so on. So the SGS OCAT back end is packaged up and ready to go. We've been able to integrate our well-established and proven curtailment analysis methodology with the fantastic ArcGIS platform, which Esri have developed. It's packaged up, it's ready to go, and we are, I think, quite rightly proud of it. However, it's been designed with flexibility and extensibility in mind, such that in the future we believe that there will be both the appetite and the potential to expand this with a wealth of additional functionality. And I think the ArcGIS platform is right there beside us to enable that. Other modeling formats, other load flow engines, additional generation technologies, perhaps energy storage systems, complex behind-the-meter orchestrated systems. Who knows? The future's bright and rosy, and yes, I look forward to it.
Thank you, Martin. He was very kind not to say the old git, Martin, versus the younger. Funny enough, I've worked all my life without Martins in my team, and now I'm up against several, so it gets a bit confusing when we refer to Martin. Is it my turn now? Right. Anyway, OCAT. I have to say, before I forget, that it's been an absolute pleasure working with Esri on this development, along with our partners SGS on our project. A lot of very clever people working within Esri, and they should congratulate themselves, because this is a phenomenal product. And I had a meeting just the other day with the head of planning, and he sees lots of potential for moving this forward. But in the first term, what are the benefits? The customer is the one who benefits initially. And then better use of existing spend data. What changes? Well, all of this relies very much upon data and the quality of that data. And as we've discovered through this project, there is an awful lot of missing data or erroneous data which we're working on. And that will probably be the only hindrance to expanding this right across our network in the short term, at least. These advanced modeling power flows are to make best use of existing assets. Evolve to model other technologies which Martin hinted on. Real-time, we probably move towards real-time thermal ratings of cables and transformers, which will give us even more capacity on the network. The active network management itself, on average, almost doubles the amount of connected generation that you can get on an average circuit or part of a system. In terms of what is next, more complex than we had a change in the slides. And I just lost my page. So, so the OCAT value, helping to improve the service provided to customers. The main advantage here really is the customer can self-determine potential connections for generation. The use of the editing tool to line the route as demonstrated. This is an extremely powerful addition to this. And has taken us way beyond where we thought we would manage to be in this project. So the only warning, as I say, it is an estimate. These are estimates that come out of this package. But in terms of the customer experience should result in more low-carbon generation connections quicker and at lower cost. And finally, just to sort of summarize the value in terms of helping improve the generation connection process, through OCAT, spend resources should work on designs that should come to fruition. There will be a better relationship between the customer and the spend designer. Open dialogue to achieve better result for the customer. And also, the other benefit, which again wasn't even considered at the beginning of this project, was that we would use this internally. Because it's become so powerful with so many possibilities, this will be used internally to assist spend in design development. Potential, well, in the future you may find quotations through this type of system, though anybody who's worked in SAT will know that I'm probably talking about 5 years ago. It's 5 years to go in terms of aligning all the various elements within that. For us, in spend, there'll be reduced admin, there'll be increased time for existing resources to work on valid applications. That's, of course, a huge benefit, means more customer time. Wider network application. As demonstrated, it was only within the trial area, which is East Lothian borders, but that will, and I say it will, be expanded north and south, so more work for these gentlemen here. That will be across various voltage levels, possibly even including transmission. And it'll also align with other modeling software that we use. Thank you very much. Any questions?
Any questions for Jorge and the Martins?
Yeah, indeed. I fully understand, and that is our wish. Even within the trial area, we are still experiencing data issues to input to this wonderful device, so we have to resolve those. But we will be looking, as you're probably aware, there's heat maps. If you go into the New Connections website that we run, currently you would see heat map of areas, and what we'll do is, as this trial area expands, as you went into that mapping, you would see an increased area available for the OCAT tool that would take place. Timescales, I'm afraid I'm not sure. Okay.
Thank you very much, gents.